Let's talk a little bit more in detail about correlation. So here are three graphs, three scatter plots, and the question is, which of the following graphs has the strongest linear correlation? So looking at this, it's kind of hard to tell. This seems very clustered together here. This is a little bit less. This has a lot more scatter, but notice it's a trick question because they're actually all the exact same graph. So obviously, instead of just relying on our visuals, we want to be able to rely on mathematics. So we want to find what is called the correlation coefficient, which is R. To calculate R, and R is a measurement of both strength and direction, so strength based on the value and direction based on the sign of a linear relationship. So whenever I'm talking about correlation, I'm talking specifically about a linear relationship. So here's our formula. Essentially what we're doing is we're finding the z-score of each x value, the z-score of each y value, and then finding the product of those pairs and then adding them up and dividing by n minus 1. So let's take a look. Here are four values, and I have a fitted line plot that I have created from them. And let's calculate the R value for height versus weight of men. Okay, totally kidding. I'm never going to make you use that formula because obviously in this class we're going to be looking at using StatCrunch to help us out. So what I'm looking for here is my correlation coefficient, which is 0.97748,505. Let me tell you what this tells us. This value is positive, and the positive value tells me that this slope is positive, which is very clear. It tells me that I'm dealing with a positive correlation between the two variables, meaning, in general, as the height of a man increases, so does his weight. What it also tells me is that this is really, really strong. I've got 0.977, and the closer I get to 1 or -1, the stronger the correlation is. So this is really stinking close to 1, so this is a really strong relationship. So let's talk a little bit more about what R means. A positive R indicates the positive linear association, a negative R indicates a negative linear association, and this is super important. I can only have an R that is between -1 and +1. So let's say I'm taking my assessment and it says R equals 1.23. Well, I know they're just trying to fool me because that is impossible. The perfect linear relationship, meaning I could connect them with a very precise straight line, this would have an R value of 1, and if it was the same association but in the negative direction, it would have an R value of -1. An R value of 0 indicates no linear relationship, but we're going to go back to my little parabola example. This would have an R value of 0, but that doesn't mean there's no relationship. It just means that it's not a linear relationship. R is just a number. It doesn't have a unit. So again, if they said R equals 0.23 centimeters, you would know immediately that that would not be okay because there's no unit. And also it doesn't change if we change inches to centimeters, etc., etc. It is still going to be the same correlation coefficient. The big issue here is that R is strongly affected by outliers, just like when we use a mean and standard deviation. If we have an outlier, the mean and standard deviation isn't the way to go. So it's non-resistant to outliers, so it might be a good idea, if you do have an outlier, to take that outlier out of your equation and do all of your calculations without the outlier, and then in your summary just say that you excluded the outlier. And before moving on, this is just a great visual to give you an idea of the kind of R value that would be associated with a type of scatter. So R equals 0, no linear association. R equals 0.4, kind of a linear association, but it's really hard to tell. R value of 0.7, notice these are more tightly clustered than the 0.4, but the 0.9 is even more tightly clustered. This is the perfect one because they're all in the exact straight line. And then negative 0.98 means now the correlation is in the negative direction, a negative association, but again, fairly tightly clustered because it's very close to -1.